Hi, my name is Jeff Orrock, the meteorologist in charge at the National Weather Service office in Wakefield, Virginia. This will be a brief presentation explaining the new probabilistic wind forecasts being generated by the National Weather Service office in Wakefield. The website for the new probabilistic wind forecast is weather.gov/AKQ Windprobs Experimental. A quick explanation of how the probabilities work and are applied in forecasting. The forecast mode is defined as the value which occurs the most often within a data set. When thinking about a range of solutions or possibilities, the top of the bell curve is defined as the mode. The top of the bell curve is where you see the most frequent solutions occurring. The actual forecast generated by the forecaster at the Weather Service office sets the mode of the forecast. So the mode can also be defined as the most likely solution or scenario. Notice that there will be values that fall to the left of the mode, which may be lower wind speeds or lower values, and also values which fall to the right of the mode, which would be higher values, or in this case, higher wind speeds. On the extremities, you have the 10th percentile, meaning that once you get to the left or below the 10th percentile, only 10% of the solutions have winds of this intensity, where once you get to the 90th percentile, again, you have the upper 10th, where only 10% of the models run have wind speeds of this intensity. The probabilistic wind forecast that we are providing is generated by a 70-member ensemble of models. Basically, we take all of the information available to us in our forecast data set and develop a statistical range of solutions. Once again, the mode is set by the forecaster as the most likely scenario. And we'll explain more about how to interpret this as we go through the presentation. So what does a probabilistic wind forecast look like? This is what you'll see when you go to the Weather Service website and look at the wind probabilities. We've broken it down to various speeds of 25 knots, which is the criteria for small craft advisories, 34 knots, the criteria for gale warnings, 48 knots, which gets into storm conditions, and of course 64 knots, which gets closer to hurricane conditions. Across the x-axis is time going out into the future, with the most current time starting here at the left, and the y-axis is the probability in percent of the various wind speeds occurring. Across the bottom you see wind barbs with in wind direction. For example, here in the middle, this would be a northwest wind of 25 knots, gust to about 32 knots. The wind barbs and the gusts provided here at the bottom of the graph are pulled from the official wind forecast. This is a 3-hourly representation of the official forecast for the given location. The lines above the forecast are the probabilities of various wind speeds occurring. So in this example, wind gusts within the pilot area of around 25 knots, the probability is around 90 to 95% of seeing about 25 knot winds or greater. This means that almost 90% of all of the possible solutions have at least 25 knots of wind. Looking at the red for the gale conditions, this shows you that there is about a 45% probability or chance of gale force conditions occurring within the pilot area. Now remember, the mode was defined as the 50th percentile. So once the probabilities of the conditions reach close to 50%, you're getting into a very likely scenario, and in fact usually our forecast will agree with a probability of 50% or greater. And you can see here in this situation we were forecasting wind gusts of 34 knots with the probability being around 45 to almost 50%. Once again, this means that we were in the middle of the statistical distribution. Once again, the website for this is weather.gov/AKQ and then wind_probs_experimental. So let's look at a few recent cases of how this could be applied when dealing with wind conditions in the port. This was a forecast for the pilot area, again forecasting the wind gusts back on November 9th. You can see here in the probabilistic wind forecast, once you get close to 6 p.m. or 1800 local time, there was a rapid increase in the probabilities of at least 21 knots of wind. After about 6 p.m., you could see a rapid increase in the probabilities of gale force conditions, with the probabilities reaching close to 60%. This means that 60% of all of our model guidance, including the official forecast, were predicting at least gale force conditions. You see the probabilities decrease fairly steadily by the time you get to around 6 in the morning. So we go back and look to see what actually happened, looking at some wind data from Cape Henry, and we can see that the wind speeds remain fairly low up until about 6 to 7 p.m. in the evening. Once again, 1800s, suggesting the winds would be increasing probabilistically to 21 knots pretty quickly. And after 6 p.m., we do see a rapid increase to over 21 knots pretty quickly in the observed data. The gale force wind gusts really do not occur until around 9 p.m. And from around 9 p.m. through about 2 or 3 in the morning, we do see a period there where we were seeing gale force wind gusts of 34 knots or greater. So going back to our wind probabilities, we noticed that the wind probabilities for gale force gusts really did not increase to over 20% until around 8 p.m. in the evening, and they peak between midnight and 6 in the morning. And that's exactly what shows here in the actual data. So the wind probabilities did a pretty good job defining the timing of the wind speeds and how the wind speeds may increase in the near term. Here's another example of a pretty abrupt increase in wind that was associated with a cold front that moved through the area, and this was back on November 19th. You can see for the hours preceding around 5 to 6 p.m. on the 19th, you saw no probability of 25 knots of wind, and so the forecast was for the wind speeds to remain fairly light, with winds out of the north at 10 knots here becoming south about 5 knots. Around 6 p.m. you see an abrupt shift in the wind. The official wind forecast goes from a southwest wind of 15 knots to a northwest wind of 25 knots, gusts to 32 very quickly, and then the winds peak out around 34 knots at around 10 o'clock at night to around midnight. Looking at the wind probabilities, you see again an abrupt increase in the probability of 25 knots of wind, with at least a 50% probability of 25 knots of wind by 6 p.m. The gale force conditions lag just a little bit, with the gale conditions occurring right around maybe 8 p.m. Looking at the observed wind speed, again from Cape Henry, we see prior to 6 p.m. Wind speeds were well below 20 knots, matching the probabilities. Once the cold front moved through the area around 6 p.m., there was a sharp increase to 25 knots, again picked up very well in the wind distribution probabilities. 34-knot wind gusts occurred starting at around 7:30 to 8 o'clock at night. Going back to the wind probabilities, it was about 8 p.m. when the wind probabilities started to increase to near 40%. As far as how long did the winds remain above 34 knots, they remained above 34 knots through about 9 to 10 o'clock in the evening. And you do see the wind probabilities here dropping off to about 20% probability of gale force conditions by around midnight. So you can see here there was going to be a brief period where the winds were going to exceed 34 knots. So again, another good example of how the wind probabilities can help give us confidence in the forecast timing of certain wind conditions across the port. Switching to the website that will be active this winter season, this is what the wind probability website looks like. You can see we are providing wind probabilities for various locations. We use the buoy numbers, so the buoy 9 is the one off of Ocean City. We have buoy 100, we have Sewell's Point, the pilot area, buoy 89, buoy 96, the Bay Bridge Tunnel, and Rappahannock Light. We are providing wind probabilities for both sustained winds as well as wind gusts. In these examples here, there's not much of a probability of very strong winds. Once again, we're using wind ranges of 25 knots, 34 knots, 48 knots, and 64 knots. We have also provided wind probabilities for a few land-based locations, including Richmond and Norfolk, once again for sustained winds and gusts. Notice that these forecasts are being provided in miles per hour. One thing worth noting that the probabilities on this website will actually update every hour. We have high resolution models that come in and update every hour, and other models which update every 3 hours. So we want to make sure that we're always providing the most recent information.